This is Module 3 of the Accelerator Onboarding track, the final module. You have already initialized an agent and worked through the entire design phase. You now have a validated DSL sitting in your repository, and this module is about what happens next. The generation phase takes that validated DSL and produces real, deployable artifacts across multiple platforms. Steps 8 through 14 cover everything from choosing which platforms to target, through compliance validation and governance planning, to handing off engineering specifications to your backend team. Step 8 is where the generation phase begins. The wizard starts by running DSL validation. It checks your DSL for completeness and structural correctness before it will generate anything. Only a valid DSL moves forward. If anything is missing, the wizard tells you exactly what to fix. Once validation passes, you choose your generation targets. The options are all platforms at once, Copilot Studio only, Bedrock POC only, Vertex AI POC only, or engineering specs only. These are separate choices because your delivery schedule may not be uniform. You might be deploying Copilot Studio to production this sprint, while the Bedrock proof of concept is planned for next quarter. Target selection lets you generate only what you need right now, keeping your output clean and your deployment focus clear. Copilot Studio is the primary production target in this workflow. When Step 9 runs, it produces a complete Power Platform solution package. The core files are solution XML, the top-level solution manifest, customizations XML, which registers all the components, bot XML, which defines the agent itself and binds its skills, and a set of YAML files, one per topic, that encode each conversation flow. Alongside those core files, the generator produces supporting artifacts, a configuration, SON file captures model settings, orchestration mode, and content moderation configuration. Adaptive card JSON files handle any card-based interactions you defined in the DSL. Power Automate flow stubs are included for platform-native integrations. Everything lands in a ZP file at the agent's Copilot Studio generated folder. That ZPP is what you import into Copilot Studio via PAC CLI, which the next slide covers, or through the browser-based solution import UI. Nothing in the output requires manual assembly before the first import. PAC CLI, the Power Platform command line tool, is the official scripted way to deploy solutions without clicking through the browser UI. It is reproducible, pipeline compatible, and faster than the browser import for repeated deployments during development. First-time setup requires 2 commands. Install the .NET SDK, then install the Power Apps CLI as a global .NET tool. You only do this once per machine. After that, deployment follows 3 steps. First, you select your target environment by running the pack.org select command with the environment URL. Second, you run the solution import command pointing at the ZIP file, using the publish changes flag to immediately publish the imported components and force overwrite to replace any existing version. That is all there is to it. Environment URLs are recorded in workflow and in the agent's front matter. 3 environments are pre-configured: dev, the BISTEC default, and your personal sandbox. Always deploy to your personal sandbox first during active development. The force overwrite flag is safe during development. In production, you would export the existing solution before overwriting. Step 10 runs automatically after the Copilot Studio package is generated. It validates the package against enterprise security standards across 3 levels. Agent-level checks cover what you directly control: authentication settings, DLP policy compliance, a hard-coded secret scan, and content moderation configuration. These checks can be fully automated against the generated files. Environment-level checks look at the Power Platform environment the agent will be deployed into. Some of these require an admin to verify DLP policies, guest access controls, audit logging, and connector restrictions. The checker flags these for human review. It cannot configure them for you. Organizational-level checks are the broadest category: data residency requirements, incident response documentation, retention policy alignment, and regulatory compliance mapping. These are documentation requirements that a human must confirm exist. The output is compliance report MD, stored in the generated folder. This is your audit trail. Fail items in the report must be resolved before any solution goes to production. Compliance is a required step, not an optional review. The compliance report is a markdown file with one section per check. Each check has a status and, where applicable, specific remediation guidance. Pass means the check passed, and there is nothing to do. Warn means the check found something worth your attention that is not a hard blocker. You should read the finding, decide whether it applies to your context, and document your decision if you choose not to act on it. Fail means you must fix this. Before production deployment, the report will tell you exactly what to fix and, in most cases, how. Manual means no automation can verify this for you. A human admin must confirm the setting in the Power Platform Admin Center. Keep Compliance Report MD committed in source control alongside the solution. When you update the agent and rerun the generation phase, rerun compliance and commit the new report. The history of compliance reports is your audit trail for every change the agent has ever undergone. Step 11 generates governance plan MD, where the compliance report answers whether the agent meets security standards. The governance plan answers who owns this agent and what happens when something goes wrong. The ownership section names the responsible developer or team, the escalation path if the agent behaves unexpectedly, and any on-call rotation for mission-critical agents. The SLA definitions section records availability targets, latency expectations, and incident severity levels specific to this agent. The incident response runbook is a step-by-step procedure for the on-call person to follow when the agent fails. The change management section records who approves DSL updates and how platform packages are regenerated and tested before going to production. The data handling section documents what user data flows through the agent, where it is stored, how long it is retained, and how PE is handled. Governance plan and is committed to Git alongside the DSL. It travels with the agent through its entire life. Every time the DSL changes significantly, this file should be reviewed and updated. Step 12 generates the AWS Bedrock Proof of Concept Output. If you selected Bedrock as a target in Step 8, the generator produces CloudFormation templates that define the Bedrock agent resource, its action groups, and knowledge base configuration. It also produces Lambda function scaffolds, handler stubs for each tool implementation identified in the DSL, and IAM role definitions with permission stubs. The IAM stubs contain placeholder values for your AWS account ID and region that you fill in before deploying. The important qualifier here is POC. This output is a starting point for teams building on AWS who want to understand what a Bedrock implementation of the agent would look like. It is not production-ready as generated. Platform-specific hardening, security controls, observability, error handling is required before it can carry any real workload. Everything lands in the agent's Bedrock generated folder. Step 13 generates the Google Cloud equivalent. The Vertex AI output uses Terraform rather than CloudFormation, Terraform modules that define the Vertex AI agent builder configuration and resource definitions. Tool definition files and cloud function scaffolds are produced for each tool implementation, deployable to either Cloud Run or Cloud Functions. For knowledge base grounded agents, the generator produces Vertex AI search data store configuration. IEM bindings and a service account setup are included, with placeholder GCP project IDs to fill in before deployment. The comparison to Bedrock is straightforward. Bedrock uses CloudFormation and Lambda, while Vertex AI uses Terraform and Cloud Functions. Different infrastructure stacks, the same conceptual structure, and the same POC status. Both require the same kind of platform-specific hardening before production. Output lands in the agent's Vertex AI generated folder. Step 14 is the final step of the generation phase. It produces engineering-specs.md, a detailed specification for every engineering dependency the design phase identified, the backend services, MCP servers APIs, and data sources the agent relies on. For each dependency, the spec includes its purpose, the API contract with endpoint signatures and request-response schemas, expected inputs and outputs, SLA requirements covering latency and availability targets, and a recommended technology stack for implementation. This file is the formal handoff to your backend team, or the next BMA'd implementation cycle. When you hand engineering specs.md to a backend developer, they have everything they need to begin building without scheduling a separate requirements conversation with you. After step 14 completes, the DSL status fields are updated to indicate that the design is complete and that generation has run. These markers tell the system, and any developer who opens this agent later, that the full generation phase has been executed. After the generation phase, here is the full structure of what you have produced. The design folder contains everything from the design phase, the DSL YAML file, requirements.md, design decisions.md, and research notes.md. All of these are committed to Git. The generated Copilot Studio folder contains the solution's IP and deployment instructions. The generated Bedrock folder holds the CloudFormation template and Lambda scaffolds, marked as POs. The generated Vertex AI folder has the Terraform file and Cloud Function scaffolds, also POC. The generated engineering folder contains engineering-specs.md. Finally, compliance report.md and governance plan, ended live alongside the solution's IP in the generated folder, not in a subdirectory, but at the same level as the Copilot Studio folder. This structure is consistent across every agent the system generates. Once you know it for one agent, you know it for all of them. An agent is not a one-time artifact. Most agents have new capabilities added after initial deployment, sometimes months later. The DSL-based workflow makes this straightforward. When you want to add a new capability to a deployed agent, you open the DSL in Cloud Code, trigger the wizard, and select the existing agent by name. The wizard recognizes it and loads the existing DSL context. Before making any changes, read requirements.md to remind yourself of what the agent was originally designed to do, and read design decisions.md to understand why existing choices were made. This prevents accidentally reversing a decision that was made for good reasons you may have forgotten. Then make surgical edits, modify only the DSL sections affected by the new capability, and regenerate only the affected platform packages. You do not need to generate Bedrock and Vertex AI output if you are only changing a Copilot Studio topic. Always rerun compliance after any significant DSL change. A new integration might trigger a DLP flag, or a configuration change might introduce a new issue. A fresh compliance check on every meaningful update is required. As you and your teammates complete agent designs, the wizard can write pattern learnings back to a shared memory store. 4 categories of patterns are captured there. Platform patterns record proven Copilot Studio topic structures, authentication flows, and adaptive card templates that worked well in practice. Integration patterns record successful connector configurations, MCP server setups, and flow stubs for common integration scenarios. Workflow patterns capture orchestration sequences and tool calling strategies that reliably achieved the intended outcomes. Compliance notes record known warn and fail patterns together with the specific fixes that resolved them in your environment. The feedback loop is straightforward. You design an agent, you save useful patterns to memories, and the next time anyone on the team designs a similar agent, the wizard reads those memories and makes better default recommendations from the start. Over time, the system learns from your team's collective experience and reflects patterns that are proven to work in your specific environment. When you complete your first real agent design and discover something that worked particularly well, save it to memories. The whole team benefits. You have now completed the full Accelerator onboarding track. Across 3 modules, you have learned how to initialize an agent, work through the design phase, and run the complete generation phase from step 8 through step 14. You can initialize an agent and complete the design phase. You can run steps 8 to 14 to generate deployable platform packages. You can deploy to Copilot Studio via PAC CLI. And you can read and act on compliance reports and governance plans. Your next step is to run through a real agent design in a sandbox environment. Take the IT-Support agent from the Module 2 exercises, or choose a domain you know well, and run it all the way through generation. The exercises for this module are designed to give you practice with the most common tasks you will encounter on a real project. For ongoing reference, Agent Building Guide, NMD in the repo root is a concise checklist of every step in the entire workflow. Keep it close when you are working on your first few real agents. Welcome to the Agent Accelerator team.